All right, everybody. So those who are asking where are my videos for YouTube reviews, if you go to Canvas, you see the exams and exam reviews module, review videos, you click on it, and you see the brief calculus exam review videos. You click on it, it will take you to my YouTube page. It has a whole playlist. I'm teaching 2 sections of 210. So there will be a 6 p.m. class. We do not want to see the videos for 6 p.m. Okay, that's not relevant to you. You look for 3 p.m. Okay, and this was part 1, which we did last week. Only 9 views. This is not good. I have a lot of students, or maybe 9 only missed the class. Okay, so today we'll do part 2. The exam reviews are posted on Canvas. And after I'm done with the review, I will post the completed notes for exam 3 here, okay, in the same module. So you get plenty of resources. I want you to do well in this exam. Now, let's begin where we left off. Everybody has the PDF for exam 3? Really?
What do you mean PDF for exam 3?
You know, the homework that I give you. Seriously? Okay, there. These are the exam reviews that we solve in class, right? I pick problems from here. Exam 3. Do this exam review as many times as you can. Exam will be a carbon copy. Every question will be picked from this file. From this file. Yes.
No, Sean.
Why would I lie to you?
No, look at my grade.
You did not study.
I swear I did. Go check the tutoring center.
Okay, let's do the next one. So we're talking about, what did I do in last class? Let me see. So this is the, no, I will pick up from where we left off last time. So we talked about 13.3. All these notes will be posted. We talked about the Riemann sum. Okay. So which topic was that? Oh, I'm going to talk about the area between curves today. You will get a question where there will be no graph, just 2 functions. And you will have to find the intersection points and plot the graphs and figure out which function is higher, which function is lower. So pay attention, okay? We'll be dealing with this problem. This is section 14.2 on your exam review. I'm going to solve question number 1. This is section 14.2, area between curves. These notes will also be posted. Area between curves. And we're talking about question number 1. So the question will be very typical in exam. Find the area of the region enclosed by. You will be given 2 curves. Here I have y equals negative x squared plus 6x plus 2. And the second curve is another quadratic. So I have 2x squared plus 9x negative 4. Okay? So I have these 2 quadratic equations. I have to find the area between these 2 curves, and I have no clue where do they intersect. So I need 2 things, right? I need the limits. So I need an interval of intersection. And if these 2 are the parabolas, I need to find which one is higher, which one is lower, right? How do I solve for the intersection points? I equate both curves. So equate both of them, what do you get? Make these 2 equal to each other. Make these equal each other and solve for x. And you will need 2 points, right? Because I need 2 endpoints, each other, and solve for x. Solve for x. So I have negative x squared plus 6x plus 2 equals 2x squared plus 9x negative 4. And I want to find the values of x. So move everything to one side. I'm going to move all the terms here to this side. It's up to you. So I got 3x negative 6 equals 0. Now, before you start applying the quadratic formula or start to factor this quadratic, divide by 3. Make it easier, right? Because you have a 3 which can be factored out. You have x squared plus x negative 2 equals 0. Now, what are the x values? Right? Everybody knows how to factor a quadratic? You got x minus 1, x plus 2 equals 0. This is exactly what you will be doing. You got x equals 1 and x equals negative 2. Or you could use the quadratic formula. Be my guest. Whatever method you use, as long as you have the correct answers, that's your limit. So you have the interval now. Interval goes from the lower to the higher value, right? Now, how do I know which function is going to be bigger in this interval? The next step. Is this clear? Everybody can equate the two functions and solve for x and get the two values. Okay, good. Now, how do I know which graph is going to be first, right? Because that's how we set up the integral. We have our limits now. And then I have f negative g, right? That's the formula we use to find the area between two curves. The higher function is f, the lower function is g. So that's what I want to find now. Anybody remembers how to find this? How to know if this function is going to be higher? Yes. You plug in a test point in the given interval. Memorize this, okay? These steps you have to memorize. So I will pick a test point in the interval to make sure that you have the right curve, unless I give you a graph. Then you know for sure which graph is higher in that interval. If I don't give you the graph, make sure you test it. Pick a test point in a negative 2 and 1 to see the greater function. Now, what is the easiest point in this interval to check? Exactly, smart choice. So I had two functions, negative x squared. I'm just going to copy them again. Plus 2, and I had the other function, 2x squared plus 9x minus 4. I put 0. Well, this will just be 2. Which one is higher? Right? I'm plugging in 0 here. So this is 0. This is 0. This is 2. This is 0. This is 0. This is negative 4. Well, clearly, this function is greater, right? Than that function in this interval. That's why it matters to find the intersection point first. Everybody can do this in the exam until here. And that's it. Then you set up your integral. So now I do integral negative 2 going up to 1. I have the bigger function first, and I subtract the smaller function. So everything will be subtracted. So I got negative x plus 4 dx. I would recommend you simplify before you integrate. So combine the like terms. Combine like terms. So what do you get? Before you integrate, okay? So I have negative x squared, negative 2x squared. I got negative 3x squared, negative 3x, and I got plus 6, right? I'm not doing anything math here. I'm not applying any integration formulas. I'm just simplifying. And now I apply the integration formulas. Everybody's champion. And if you're not, practice all the problems on the exam review. How do I integrate this thing? I quotient, add 1 to the power, and divide by it. And if you have a constant, you just multiply it by and x. This is a definite integral, so you have one extra step to solve here. What will happen? I make two big brackets, separate them by a negative. In the first bracket, I put 1 everywhere. So I got 3, 1 cube over 3, negative 3, 1 square over 2, plus 6 times 1. In the second bracket, I put the lower limit. So I have negative 3 times negative 2 cubed. You can use your calculator for this. Negative 3, negative 2 square over 2, plus 6 times negative 2. Right? And then you do all the math. Somebody has an answer for me? Yes, Casey. You have to be more confident. Somebody, what is the answer? 0.7 over 2.
It's supposed to be minus, it's supposed to be minus 4.
No, I'm subtracting it, right? So this will be a plus 4. Because you're subtracting this function from this function. So everything will change sign. Right? I'm subtracting negative. So this will be negative, this will be negative, but this will be positive. So check your answer. Casey says it's 0.27 by 2. Oh, 27 by 2. Oh, that sounds more right. I was like, that's too low. Okay, this makes sense to everybody? Can you do this in the exam? It's gonna be a long problem, but it will be divided in subparts. So each part will be worth some points. Part 1, solve for the intersection points. Part 2, let's do one more. I'm talking about number 3 now on the same section. Question?
Can you scroll back up to the F minus really quick, all the way up one of them? Go back up. See that function right there? Is that equal to F minus b? So just go back down. She basically just took those two and she wrote
Okay.
out this function, the one on the left, minus the one on the right, but she just didn't show us her actually multiplying out negative 1 times 2x.
Wait. Rob, is this what you're asking? I'm subtracting. Yeah, I'm changing all the signs, right? I'm subtracting. Okay, Rob, this makes more sense that I'm subtracting this whole thing from this. So what will happen? This will be a negative, this will be a negative, this will be a positive. Right? Yeah, just try to solve it on your own. You know the process now, right? Everybody can memorize the process at least. Okay, let's do number 3 on the same page. Number 3 is slightly different for MCQs and stuff. So you are supposed to find the area between the curves y equals x squared and y equals -1. And you're already given the limit from x equals -1 up to x equals 1. Right? So the limits are already given. The x values are your limits. It goes from -1 to 1. Now, all I have to decide which function is going to be greater, this one or this one. Again, I'll pick a test point. Pick a test point in the interval. Say I pick x equals 0, right? That's the best choice. Now, I have two functions to check. This function will not change whatever x you plug in. This function becomes 0. Which one is higher? Clearly, this one, right? Make sense? So the process, the steps are the same. So you're subtracting the smaller function from the bigger function. You got -1 to 1 x squared. And everybody can integrate this part. Question, anybody? 2 steps. I have to find my interval. I have to plug in. That's it. Don't forget to check which function is higher unless I give you the graphs, then you know for sure. And make sure you go through these videos to double check your work. Now I want to do one problem from 13.4. It's the application part, but it's just setting up the integral that you should know. Question, Zoe.
You don't have to do the whole like combined step thing.
Combined step.
You don't have to do which one was like trigger.
That's what I did.
Oh.
This was an easy problem. It's just that. But there are no like terms, right? That one was a difficult problem because it has a big quadratic with 3 terms, and the other function also had a quadratic with 3 terms, and then we combined because there were like terms. Now let's integrate this. Let's see if we can integrate. Everybody do this on your paper. See if you can do it. You have to complete this question in the exam. So x squared plus 1 dx, what do you get? The integral of that would be just, and then you plug in the limits. I make 2 big brackets. I separate them by a negative. First bracket, I put 1. Second bracket, I put -1. Right? And be careful with the negatives here. So even if you're using your calculator, make sure you're plugging in the right signs. So, and you're using all the brackets that are needed. So this will be -1/3, and this will be negative +1, right? So I got 2/3 plus 2. This is just math now. Adding numbers. Good? Everybody? Okay, let's do one from 13.4. I'll just show you how to set up the integral so that you can do it in the exam if you get a conceptual question. 13.4 is applications of definite integrals. The major part is to make sure you're setting up your integral correct. I'm going to talk about question number 1 from the review list. So this is section 13.4, and I'm talking about question number 1 from this section. So look, they're giving you the velocity function, and so they have given you that the velocity is -t² plus 8, and they want to find the total displacement between t equals 2 and t equals 6. This exam will be all about integration. How do you solve this problem? I want to find displacement, the total displacement between these 2 seconds. Clearly, that's the limit, right? And I have to integrate. The variable here is t. Can everybody do this? What is the integral? So I got -t³ plus 8 times t, right? And I do the definite integral part. So make 2 big brackets. For this, I recommend that you plug it all in your calculator. Good, everybody? Okay, how will you set up the question for number 3? So number 3 is, since YouTube became available the rate at which video has been uploaded is given by some function in the, this is number 3 from the same section. Anybody has a fine answer for me? Nobody is even trying. Plug numbers in your calculator. You have to be fast at this. 37. Okay. That's the displacement then. Number 3, you're given the YouTube thing. The function is 1.1 t squared negative 2.6 t plus 2.3 million hours of video. T is going from 0 to 9. Now that's not your limit. See that they try to confuse you here, right? This is not the limit. This is not the limit of your integral. You have to see where it begins from. So look, read the question again. It starts from mid 2005. So t equals 0 is when? It's 2005, right? So be careful. Now, what do they want you to find from? Use a definite integral to estimate the total number of hours uploaded from 2007 to 2010. So they want you to find from the total number of videos 2007 to 2010. What is that t value? T equals 2 up until t equals 5. Now these are your limits for your integral. Okay? And that's it. Once you have the correct limits, then all you have to do is integrate. Integrate going from 2 up to 5. Function is given to you 1.1 t squared 2.6 t plus 2.3 dt. Right? Anybody, any questions with this? Read the, okay, this is what I highly recommend. Do this exam review, which I've posted on the website on Canvas, at least twice. Read the questions and solve it on a blank paper. Just make sure you remember the steps, okay? Alrighty, so now we can begin. This is it. I can give you a few problems to work on unless you have a problem for me. Let's do one thing, one question of natural log integration, just some review that you want. Okay, just a refresher, it's not from the review. What is the integral of this function? Just to brush your memory, refresh your memory. Raise hand if you know. Okay, not many people are raising hand. Why? Okay, good. All of you should know this formula. This is ln x. Okay, this was easy peasy. I know. Let's give you this one. What is the formula for this? Okay, still the people can answer this one also. What about this one? Don't answer, Casey. No, quiet. Raise hand if you know. If you're not going to raise hand, I'll still call you. Huda, are you here? Yes, what will you do? How do you solve this question? How many think I should move the 4 up? Good job. You think I should move the 4 up? Okay, look, how do we solve? This is, okay, for exam, there's a reason I picked this. Yes. No flipping here. Okay, look. I would move the 1/4 outside the integral. It's a constant. Numbers don't go up. numbers remain in the denominator. If you see a number in the denominator, it will stay there. What is the answer now? See the error? Everybody would do this? Well, now you know. What about this one? Let me ask you one more. What about 1 over 4 x squared dx? It's just a random question. I want to just make sure you know the concepts. Anyone? Come on. Is there coal here? Coal? Okay. Khalid? Oh, I know you know. Casey? Now remember one rule. Number stays in the denominator. Good job. So you keep the number out of the integral. That doesn't change. But x becomes negative, right? And now I can apply the rule of integration. I add 1 and I divide by the same thing. Can everybody do this? You could leave it here in the exam. I don't mind. The answer is, and then this would be 1 over negative 4x plus c. If you finish the assignments at Xfinity, you should know how to get the power to be positive. But in exam, even if you leave it here or here is good. Just be careful. Numbers in the denominator stay in the denominator. If I see you in exam moving those up, I will be mad. Okay? Okay, now we can begin the quiz.